All right, today we're pulling back the curtain on one of the most fundamental rules in all of electronics. This is the secret principle that makes sense of the chaos inside every single gadget you own. So, let's jump right in.
I mean, have you ever really looked at a circuit board? It's just this dense, buzzing city of components and pathways. It looks like a completely wild, tangled maze, almost impossible to navigate.
So, that's the big question, right? How on earth do engineers manage that chaos? How can they possibly predict what's going on in there to make sure your phone actually works or your car starts every morning?
Well, believe it or not, the answer is this incredibly simple, just elegant solution that was figured out way back in the 19th century. It's a rule that brings a beautiful sense of order to all that mess.
And the key came from a German physicist named Gustav Kirchhoff. He came up with a couple of laws that literally became the foundation for all modern circuit analysis. Today, we're zeroing in on his second law.
Officially, it's called Kirchhoff's voltage law, or KVL for short. But you'll also hear it called the loop rule. And honestly, that's my favorite name for it, because you're about to see just how perfectly it fits.
Okay, so here's the textbook definition. The algebraic sum of the voltages around any closed loop in a circuit is equal to 0. I know, that sounds super formal and a little intimidating. But the actual idea behind it, it's surprisingly simple. To really get it, let's just push pause on circuits for a second. Instead, let's think about something we can all visualize, like going for a hike up and down a mountain.
So let's try this analogy. Think of a battery, a voltage source, as being like a ski lift. It does all the work to take you up the mountain. That's a gain in elevation. Now, components like resistors, they use up energy. That's like skiing downhill. You're losing all that elevation you just gained. So what's a closed loop in a circuit? Well, it's just a round trip. You start at the lodge, you take the lift up, you ski all the way down, and you end up right back at the lodge. So, what's your net change in elevation? 0. Exactly 0. You're right back where you started. That's it. That is all Kirchhoff's voltage law is saying.
All right, so the theory is cool, but let's actually see this thing work. Let's walk through a real circuit and put KVL into action.
Okay, first things first, we need to find our hiking trail. In any circuit, this is just a closed path that the current can take. For a simple circuit like this one, it's pretty easy to spot. There's one obvious loop to follow.
Next up, we just have to decide which direction we're walking around the trail. Let's just say we're going clockwise. As we move, when we go through the battery from the negative side to the positive side, that's our ski lift, an uphill gain in voltage. And when we cross a resistor, that's our downhill run. That's a voltage drop. And now, we just walk the loop and add everything up as we go. We get a big energy boost from the battery, so that's a positive voltage. Then each resistor uses up a bit of that energy, so those are voltage drops. We subtract them.
So let's put some real numbers on this. Say our battery gives us a 12-volt uphill gain, and let's say the first resistor has an 8-volt downhill drop, and the second one has a 4-volt drop. What do we get?
0. A perfect 0. It has to be. The 12 volts of gain from our ski lift is perfectly balanced out by the 12 volts of drop from skiing downhill. You're back at your starting point. This isn't just a neat trick, it's a fundamental law of physics. It always has to balance.
Okay, fine. So we can balance a tiny, simple circuit. That's neat. But why is this one rule so incredibly important in the real world?
Because that simple principle of balance, that's the absolute bedrock that lets engineers design every single electronic circuit you can imagine, from the simplest toy to the most advanced spacecraft. Without this rule, it would all just be pure guesswork.
And trust me, KVL is the silent hero working behind the scenes everywhere. It's being used to manage your phone's battery so it doesn't overcharge. It's used to analyze the entire power grid to keep it from collapsing. And it's absolutely critical for designing things like pacemakers where, getting it wrong just isn't an option.
So really, the main takeaway is this. A super simple, intuitive rule about taking a round-trip hike is the very thing that makes all of our complex technology predictable, safe, and reliable. That electrical maze we saw at the start, it's all built on this one elegant idea of perfect balance.
And that kind of leaves you with a final thought, doesn't it? It just goes to show you that underneath some of the most complex things in the universe, you'll often find a simple, powerful rule. So, what other simple rules do you think are out there hiding in plain sight, just quietly running our world?